Today we are going to discuss physical properties of aldehyde and ketone. So let's read from the book. The physical properties of aldehyde and ketones are described as follows. Methanol is gas at room temperature. Ethanol is a volatile liquid. Other aldehyde and ketones are liquid or solid at room temperature. The boiling point of aldehyde and ketones are higher than that of hydrocarbon and ether of comparable molecular mass. It is due to weak molecular association in aldehyde or ketone, arising out of dipole-dipole interaction. So in aldehyde and ketone, there is dipole-dipole interaction. Also, their boiling points are lower than those of alcohols of similar molecular masses due to absence of intermolecular hydrogen bonding. So in aldehyde and ketone, there is absence of intermolecular hydrogen bonding. That's why their boiling point is less than that of alcohols. The following compounds of molecular mass 58 and 60 are ranked in order of increasing boiling points. So when you compare the boiling point of different molecules, the first one is hydrocarbon and butane. All the molecules have comparable molecular mass. They ranges between 58 to 60. Methoxyethane, it is an ether and its boiling point is slightly more than that of hydrocarbon. Propanol is an aldehyde. Its boiling point is slightly higher than that of ether and this is acetone. Acetone is a ketone and its boiling point is more than that of aldehyde. Propane 1-ol, it is an alcohol. Its boiling point is highest among them. The lower members of aldehyde and ketone such as methanol, ethanol and propanone are miscible with water in all proportions because they can form hydrogen bond with water. Here this is ketone. These two are the molecules of ketone. They can make hydrogen bond with the water molecule. So here you can see how these ketone molecules can form hydrogen bond with water molecule. However, solubility of aldehyde and ketone decreases rapidly on increasing the length of alkyl chain. Let's try to understand why the solubility of aldehyde and ketone decreases on increasing the length of alkyl chain. So alkyl chain is made up of hydrocarbon. So if we take the example of propanol, it consists of 5 carbons. So let's draw the structure. 1, 2, 3, 4 and this is 5th carbon and there is aldehyde functional group. Now balance the hydrogen. So here CH3, CH2, CH2 and this is CH2. There is electronegativity difference between carbon and oxygen. That's why the oxygen becomes electronegative and carbon develops delta positive charge. And due to this the molecule is polar. So aldehyde is a polar molecule. But in alkyl chain, there is no electronegativity difference between hydrogen and carbon. That's why this part of the molecule is non-polar part. So it is a non-polar part of the molecule. So when you increase the length of alkyl chain, the non-polar part of the molecule increases. That's why on increasing the length of alkyl chain, solubility of aldehyde or ketone decreases in water. Now let's read from the book. All aldehyde and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. The lower aldehydes have sharp pungent odor. As the size of molecule increases, the odor becomes less pungent and more fragrant. In fact, many naturally occurring aldehyde and ketones are used in blending of perfume and flavoring agents. Now let's try to solve this question. Arrange the following compounds in increasing order of their boiling points. Now first of all, identify the molecules. First one is 4 carbon containing aldehyde. So it is butanol. So let's write down the name of the molecule. It is butanol. The next one is 4 carbon containing alcohol. So it is butanol. So it is butanol. Next one is ether. So write the name of the molecule. It is ethoxyethane. So it is ethoxyethane. And the next one is butane. Now identify the intermolecular force of attraction in these molecules. In butanol, aldehyde functional group is there, and due to aldehyde functional group, this molecule is polar, so there will be dipole-dipole interaction. So there will be dipole-dipole interaction along with van der Waals force of attraction. In case of butanol, there is dipole-dipole interaction along with van der Waals force of attraction, and there is most strong force of attraction is hydrogen bonding. Ethoxyethane is again polar molecule. So here it is a polar molecule, so there will be dipole-dipole interaction in ethoxyethane. But in case of butane, it is non-polar molecule. So there will be only van der Waals force of attraction. So there will be only van der Waals force of attraction. Butanol has carbonyl functional group. Due to presence of carbonyl functional group, the dipole interaction is stronger as compared to ether. And you know, boiling point is directly proportional to the force of attraction. Force of attraction between the molecule. In case of alcohol, there is strongest force of attraction, while in case of butane, there is least force of attraction. So butane will have least boiling point because the force of attraction in the butane is the weakest force of attraction, that is van der Waals force of attraction. After butane, there will be ethoxyethane because in case of ether, there is dipole-dipole interaction, but this dipole-dipole interaction is weaker than that of aldehyde. So next will be ethoxyethane, then aldehyde. So here this will be butanol, and after butanol the strongest force of attraction is present in alcohol, which is butanol. So butanol will have highest boiling point. So the same thing is given here also in the explanation when you read. The molecular mass of these compounds are in range of 72 to 74. Since only butane-1-ol molecules are associated due to extensive intermolecular hydrogen bonding, therefore the boiling point of butane-1-ol will be highest. Butanol is the more polar than ethoxyethane, therefore intermolecular dipole-dipole attraction is stronger in the former. N-pentane molecule, there is a mistake. It is not N-pentane because it contains only 4 carbon, that is N-butane. So this molecule is N-butane. Have only weak van der Waals force of attraction. Hence the increasing order of boiling point of the given compound is as follows. So here also it is hydrocarbon. After hydrocarbon, ether is there. Then aldehyde will have more boiling point as compared to ether, and alcohol will have highest boiling point among them. Now let's try to solve this Intext question. Arrange the following compound in increasing order of their boiling point. So here the first one is aldehyde, second is alcohol, third is ether, and the fourth one is hydrocarbon. We just have solved such type of question. So here you know hydrocarbon will have least boiling point. After hydrocarbon, ether will be there, then aldehyde and alcohol will have highest boiling point. So here when you arrange them, you will get propane. So propane will have least boiling point. Propane. After propane, there will be ether, methoxymethane. So here methoxymethane. After methoxymethane, this aldehyde, it is acetaldehyde or ethanol. After ethanol, ethanol will have highest boiling point. So here you can write ethanol. Ethanol will have highest boiling point among them. In the next video of this chapter, we will discuss chemical reactions.